Hey, what's up guys? My name is Silva. Today we're going to talk about material glossiness. In front of me I have a panel with three surface types. We're going to go right into a matte surface. Now by nature, a matte surface is kind of rough looking, right? And if it's not, uh, on a molecular level, it'll still be rough looking. For example, if you grab an object and you pass your hand through it and it feels rough, most likely there's not going to be much glossiness or specularity on it. If you do have an object where you do pass your hand over it and you're like, it kind of feels smooth, right? And it still looks matte, most likely it's because on a molecular level, the light anyway is gonna lose its intensity, and it's not gonna be strong enough. The bounce light is not gonna be strong enough to make it look either glossy or mirror-like. And this is what it's happening here. In orange, the sun would go down and the sun rays would hit this matte rough surface, and then it's gonna go in all directions. The bounce light in yellow here is gonna go into all kinds of direction, and once it does that, it's gonna do two things. It's gonna lose strength, and all the directions, all the sun rays, once it's being bounced off and it goes on an opposite direction, your eye is not gonna catch that as much as the rays that are gonna go directly into your eyeball, as a couple of ones here. So in this example, this area around here most likely would be the brightest, right? Moving on to glossiness. Glossiness is a mix between matte and mirror. Now, exact same thing. We have a round surface here. The sun goes in and hits. Now, the difference between the glossy and matte is that if you notice, there's smooth breaks in between these little um, dots, or these little speckles here, right? Now those breaks in between is actually make it the light rays bounce off perfectly into our eye, or whatever direction the sun is going to. So in this case, from left to right, the sun is going down, and once the light rays bounce off from the surface, the strength of the light rays are going to be much stronger than on a matte surface in some areas, but still in others you can see some of the light rays are actually going to bounce away or in a total different direction. So you're going to have much more stronger specularity, right? You're going to see more highlights, but not as much as the next example, mirror. Now the mirror, the sunlight comes in and there's a perfectly smooth surface. Also, on a molecular level, the sun goes down, and then once it bounces off, both the strength of when it hits and the strength of bouncing off light rays are going to be nearly equal, if not equal. Um, and that's why you can see yourself in the mirror, for example. Now, there's a few examples, or a few differences of a mirror-like. Um, but before we get into that, actually, I have a couple of examples here I can show you right now. So, for example, a matte surface. I have a pillow here. I got my couch pillow, and if you notice, let me get here really. If you notice, this has like it has a fluffy kind of texture to it. It's very, very similar to what I drew here on the matte example. You can see these little dots right underneath. It just shows, if we would see it right from the side and on a straight line, what kind of speckle uh, texture we would have. Now here on the glossiness, I have one example. You have a cup, for example. You see this? This is pretty glossy actually. Almost mirror-like. You can pick this up from the camera much more than I do. In real life, I can actually barely see the reflections. But this is a very glossy kind of uh, surface type. And last but not least, obviously, we got our trusted mirror. You guys can see yourself right there. So it's all fun. Oh yeah, and above each example, you can see in a ball what kind of uh, result you'd be given on a matte Gaussian mirror. Now, moving on, there's still one special material surface, and actually it's two of them, semi-transparent and subsurface scattering. Now, when I say special, I mean it's not as common. Aside from the semi-transparent, we have tons of semi-transparent things, but subsurface scattering doesn't happen as often and not as like in this picture right here. How many times would you see that, right? It's not so common. So let's start with semi-transparent. It says this occurs when a significant portion of light passes through a material which then is reflected diffusely. So basically, in other words, sunlight comes in, hits this semi-transparent surface and penetrates it. Now, the penetration on the semi-transparent is actually because the material is semi-transparent, the light can bounce a lot in between the layers of that material, and that's going to cause it for you to be able to see what's inside of it, right? Or kind of semi-transparent, obviously. Once that happens, it bounces inside of it and also at the surface. Whatever light is inside and it bounces away, the strength of it is much weaker, but you'll still be able to actually tell the surface, middle, and what's inside of this semi-transparent material. One example here I have is this, I believe this is a lamp, what you call it, like a lamp cover. It could be made of paper, made of like a very thin layer of marmor. Yep. There's a few examples. Now, subsurface scattering. It says, same as semi-transparent, however, less light passes through a material and its strength decreases greatly. Now, it's very similar to semi-transparent, but there's two things that make it a little different. Number one is the thickness of the material. Usually on a subsurface scattering, it's much dense, right? For example, in our skin, our bones and muscle and anything else that it's organic as well, the thickness of it usually is a bit more dense than semi-transparent. Now, the subsurface scattering, once the light does exactly the same as the semi-transparent, light goes in, bounces around inside, then goes out. Now, with subsurface scattering, the same happens, but the light doesn't come out as much. The light is much more condensed inside of the material, and then just a little bit of it can come out from, the light can come out from, let's say in this case, the skin and muscles, right? And with that said, I think it would be fun to actually show you guys maybe a little experiment that I tried myself. And while it might not be 100% accurate, I think it's still pretty cool to do, and you'll have a better idea of how light even my work, and you'll be able to portray your illustrations, whatever you're drawing and painting, form much better. Now here, experiment exercise. So if you have a bouncy ball, you can just grab one by one, whatever. The smaller the better, I think. At least in my personal experience, the smaller the better. Now when you're gonna try to find a rough terrain, in this case this kind of rocks would be the best, and once you throw it, you're gonna see where is it gonna bounce off from. In this case, you probably can get a pretty good guess that it's gonna be, you're not gonna guess very well actually where it's gonna come out. The result of you throwing a bouncy ball on a bunch of pebbles, who knows in which direction it's gonna go. It can go right at you, it can go away from you, who knows. Now the throw strength, I would like to think that the throw strength would equal the light strength. So if you throw it very gently, then the bounciness of it wouldn't be as hard, as opposed to really smacking it down and then bouncing away quite hard. I believe that that actually helps me a lot in my, when I'm trying to portray light in my illustrations, and I think it would help you as well. Now, second experiment, same thing. Actually, the first experiment would be kind of like a result of how it would be on a rough, matte surface. Now, the second one would be on a kind of glossy type of surface. So you do exactly the same thing. You throw a bouncy ball down on the surface, and you probably can guess much better where the ball is gonna, which direction the ball is gonna bounce off to. And on the last one, you probably could guess as well, it's exactly the same thing, but on the smoothest floor you can possibly find. Right, one that doesn't have any tiles in it. It's just completely smooth. You almost can see your reflection in it. I actually really like doing this back then, and gives you a good perspective on what possibly the light could behave. Right now, I hope you enjoyed this little explanation. I'm gonna move on to me doing actually a rendition of a rough, glossy, and mirror-like materials. So yeah, see you soon. Alright, so we're gonna start with the matte material. On the left side, you can see that I have the little drawing of the matte surface. Just give me an idea. If you're going along with what I'm doing, you can uh, just copy what I've done on the left side and have that as a reference as well. And let's do a little, I was gonna do a little ball, but actually let's do a little kind of matte plate right here. The brush I'm using, if you notice, has a little speckly kind of texture, which is gonna help us with the matte finish later on. And before I choose any light source, I'm kind of just drawing a simple shape. It's very important that you figure out simple shape first, and then you can always draw in your light source. Now the strength of your light source is also important to each individual surface. In this case, I want my light source to be a little on the soft side. It's gonna bring out the uh, the matte quality of this texture a little bit more. And also, I want it to be at an angle, because if the light comes in at an angle, it's going to show more easily textures. And if I can show more easily textures, means that I can show that it's more matte more easily. Right, so I drew in a little shape here. Not really know what this shape is, but it doesn't matter. We should be able to paint in whatever shape we draw. The fundamentals will always be applied the same way, so it's not really a problem. Now, let's identify the shape before we actually put in the light. I'm gonna make a new layer. I'm gonna grab some red. Now, before we actually draw in the light, let's imagine you have this shape with you, and you have a pen, and you just make a line across it following the shape, right? This is what we're gonna do here. We're gonna visualize what kind of shape it would have if we would draw across it with a marker or any pen that you would have available. Actually, that's a good exercise. If you have something you can draw on, like a cup or plastic material that you're not going to use it, grab a marker, draw over it, turn it around, and make sure that you've seen it from all angles, right? So I'm going to do that really quickly. I'm not going to be too accurate with it. It's just to give us an idea. All right. Hold on. All right. It's going to be enough. And now we're going to do exactly the same thing, but horizontally. I apologize. I meant vertically. So we're going to imagine we have a pen. Draw this over, and then it's going to go across. Like so. I don't want my line to be perfectly straight, because that's also going to indicate that our surface is now on the rough side. Try to really focus on it. This is important. Um, while this is not directly connected to a material's glossiness, it is, however, connected to a material's shape, and that's also very important, because its shape can bring out more or less of its material. Let's see here, this. It resembles kind of a 3D model wireframe. If you guys don't know what that is, just give it a quick Google. 3D wireframe, and you'll be able to see a lot of this kind of horizontal and vertically lines going through a model's body, 3D model's body, not a real. If you have a real model's body, then I guess you can. Oh man. Okay, so I'm gonna do one last time here. Sorry, like so. It goes across like that. And there you go. I can see some couple of mistakes, but that's okay. It's a practice. Now that we've done that, we kind of memorize the shape. I'm gonna put that down, and right now I can see the red lines without actually having it on, because it's in your mental library. That means that I can automatically do these little quick fixes. All right, so let's choose in the color. I'm sorry, let's choose in the light direction. Right after I make this a little darker on this side. Now, I want my light to come from the top right. What do you guys think? Top right? Kind of top right. Let's say like this. Like so. Huh? The light comes and it shines. Oh, well, in this case, if it's the sun, then it would be straight rays. And we have that. So from this side, actually let's skip that. Put it on a, no, it's okay. It's okay if it's on the same layer. Put it in that, and we're gonna start rendering our shape. Now, because it's matte, I'm gonna be very aware of how light and how dark, the difference between light and darkness. I don't want to go too far. If you go too far, right, from pure black to pure white, then it's gonna start looking glossiness, because matte doesn't have very bright light. It can, however, have very darks, in fact, but not as much as if an object was glossy, and there would be, a shadow or something where it would reflect from. Um, I'm gonna paint quickly this. Now it's gonna get stronger on the right side. Like so. I'm gonna bump in the lights right now. Now I'm gonna click on this icon, this checkered kind of looking icon, and what that means is whatever I drew in the shape, it's gonna get locked. It's just gonna make my life a little easier on painting this without making such a big mess. Now I'm gonna unlock it, and I'm gonna manually fill in some of the areas where it's not picking up as good. So yeah, I'm gonna finish this, and I'll catch you guys in a little bit. So here we have it, our matte shape. It's kind of like a pillowy kind of shape. Not really sure what it is, but it's interesting enough and has enough curvy kind of shape to show a few levels of the lightest light and the darkest dark. If you notice, I painted in the little arrow that indicates the light source. Let's pretend that our light source would be that bright, right? And close to this matte shape, it would have this kind of, at least I believe it would have this kind of light intensity. Um, so yeah, I hope you learned something, and I'll see you on the next material.